Good evening and welcome to this second live interactive session for the NPTEL course, A Brief Introduction to Microsensors. The course code is NOC24 EE09. The course instructor for this course is Professor Shantanu Talukdar from Department of Electrical Engineering and Computer Sciences, IISER Bhopal. My name is Amay Dukle, Prime Minister's Research Fellow, Department of Mechanical Engineering, IIT Tirupati. I will be the mentor for this session. So I'll just start. I hope I'm audible and my screen is visible. Let us begin with the session. But before we begin, just giving you a few points. This live interaction session is to boost your performance. It is not compulsory, it is highly encouraged because it will give you some perspective about how the questions are asked and how they have to be approached. I would request you to be respectful in chat, and if you have any questions, you can ask at any point by unmuting yourself. And there'll also be a question answer session at the end of the after the teaching is done, at the end of the session. And likewise, the videos will be uploaded on YouTube. I guess you have received the public page where you can get the link to the course material and the YouTube video, so you can access the video and the course material from that link. So just to give you about the session plan, so we have 3 TAs actually for this course, me, myself, Nalin and Vaishali. So all 3 of us have their own session plan and work independent of each other. So I would encourage you to go through everyone's lecture because you might get something important. You can go through the YouTube videos as well. It's not essential to go through the sessions during the live session. So I would recommend you to do that. So my session, I will be taking a revision of the important concept that have been covered in this second week. Then we will be discussing practice assignment 2 and previous year assignment for practice, and then we'll proceed with the question answer session. So this is the course outline. This is a 4-week course. This is the second week. We will be discussing about the fundamentals of stress and strain, electrostatics, and energy dissipation. This week we mainly learned about electrostatic, coupled electrostatics, and stiction. These are the 3 important concepts that we learned in this week. So we just revise them. So the first thing which we learned in this week was the Coulomb's law. So basically, when there are 2 charges in space, whether they are if they are of different charges, if they are like charges, so if it is Q1 and Q2, they will repel each other. And if they are unlike charges, so if it is a negative charge and a positive charge, they will try to attract each other. The force with which these 2 charges attract each other in free space is given by 1 by 4 pi epsilon naught Q1 Q2 upon r square. R square is the distance between them. So 1 by 4 pi epsilon naught is given as a constant, which the value of which is 9 into 10 raised to 9 Newton meter square upon Coulomb square. This is minute in the vacuum, and if it is inside any medium, the permissivity constant for that medium we also take take into has to be considered. So the formula will be 1 by 4 pi epsilon naught er, that is the relative permissivity permissivity constant, q1 q2 upon r square. So the next concept which was covered in this week was the Gauss law. It is basically the electric flux that has been generated by a point charge can be given by the Gaussian equation, and if you see, you can correlate the Gaussian equation with the Coulomb equation and get the force for a single charge. So likewise, these two are a very important equation. Then the third concept which we learned this week are the formulas for capacitance. So what is the formula for capacitance? The formula for capacitance is EA upon D. That is, E is as I said, relative permittivity and absolute permittivity in the vacuum into area of the capacitance, area of the plate, and the distance between them. So the distance at which the two plates are being separated is the D. A is the cross section area of that plate. Epsilon 0 and epsilon r are the permittivity constants. So coming to the next concept which was discussed in this week is the pull-in voltage. So basically, pull-in voltage, whenever you have beam being separated, whenever you have a capacitance being separated and it is connected to a mechanical spring. So you can see that the mechanical force is constant. So mechanical force is constant, but the voltage will vary depending on the distance. So the pull-in voltage is the voltage below which the electrostatic attraction and electrostatic repulsion, the mechanical force act. So for the gap to be maintained between the capacitor plates, the voltage should always be higher than the pull-in voltage. So that is something which you need to keep in mind. And the critical distance at which the pull-in voltage takes into consideration is d by 3, and the pull-in voltage is given by the formula 8k d cube upon 27 epsilon naught a. So these are the two things you need to understand about the pull-in voltage. And the last concept that was discussed here in this week was the stiction. So stiction is a very important concept. So basically, whenever you do MEMS, you will have to do fabrication. So fabrication will be done on a silicon substrate. So after to make a freestanding surface, you will have to develop a sacrificial layer. So once the sacrificial layer is etched out, there will still be some fluid that will be left, and that fluid will try to pull it downwards. So, and that will cause static friction. So there will be static friction caused due to that sacrificial that fluid that will be there while etching out the sacrificial layer. So that that phenomena is called as stiction, and to remove it, basically we need thorough drying, or else we use a rinse fluid like methanol and those things, so that the surface tension of the fluid is reduced, and the adhesion of the fluid of the liquid droplet is minimized, and there is no friction basically between the two surfaces. So these are the important concepts that were discussed this week. So let's begin with the practice assignment 2. Is there any doubt now? I'm taking it as a no, and I'll start with the future further slides. So the week 2 practice assignment. So this is the first question. 4 particles each with charge q are placed in the corners of a square. Another charge q of opposite sign is placed at the center of the square such that the total force on each of the 4 particles is 0. Which of the following relation is correct regarding the charges q and big Q and small q? So small q is 0.96 times big Q. Big Q is 0.96 times q. Small q is 0.76 times large q, and large q is 0.76 times the small q. So any guesses? Any guesses? Or anyone knows the answer? Okay, so let's begin. So here we have a square. We have put all the charges at 4 edges that are the small q charges, and the big charge the big Q charge is at the center. So basically now if you actually consider the entire square, it will always be in equilibrium, because all the 4 charges will cancel out each other, and only the big Q will remain. So to actually find out, what we do is we find equilibrium along only one with only one charge. So we find the equilibrium between big Q and small q only like just at one edge. So one small q and one big Q is all that we do. So we develop the equilibrium. We use the equilibrium equation along the line OC, and from that we basically use the Coulomb's law. So here K stands for 1 by 4 1 by 4 pi epsilon naught. So using that relation, we basically find the relation between Q1 and Q0. So by solving this and basically using some basic trigonometry, we get the answer is answer B, Q 0.96 Q. Everyone understood? If they didn't understand, so we'll move with the second question. This is a quite a easy question. So basically we have two concentric metal shells with radii A and B, where A is smaller than B, then the capacitance will be. So I'll just show you the derivation. Basically here what we are doing is we know what is K. So then we find out the potential at cell. So Q is equal to CV. So So C is equal to Q by C. So using that, basically we find the potential at each of the shell, considering they are separate to each other, and then we get the potential difference and again substitute in the capacitance equation, and we get the following relation. I hope I'm clear. So this is the answer. The answer is 4 pi epsilon naught AB upon B minus A. So moving to the third question. So this is basically, these are the type of questions which you can expect in exams more than anything else. So here we are basically given two types of two statements. So one is we are given the formula for a normal force and a tangential force, and the second one we are given one condition that if x is way greater than d, tangential force will be greater than normal force, and then we have to determine like whether one is correct, two is correct, whether both are incorrect or both are correct. So these are the type of questions you can expect in your exams. So make sure to practice them. So beginning with this question. So basically we have both the relations, and the both the relations are true. You can find out in your um, in the course note. So that is always true. So then we basically do change take the entire. So if you can actually see that b epsilon naught v square by 2d, we consider it as k. So ft becomes k, and so whatever is extra, so basically x by d square, x by d is extra, so that comes in fn, that is the normal force. So basically we then if we just try to correlate them, we know that x is way greater than d, so x by d will always be greater than 1. So because since d will be small, it will be greater than 1. So if we correlate them, we will always get the normal force is greater than tangential force. So the right answer is option B. So any questions, any doubt till now? Okay, so moving to the next question. So basically this is a very simple question. This is something which you need to know by heart. But yeah, so electric energy density in the parallel plate capacitor with plate area A, gap between the two plates D. If the electric field inside is E, then the electric field density is given by which of the following equations? So basically charge is epsilon. The charge on one plate can be given by the epsilon naught electric field density into the area. So electric field density into the area can be converted into charge in the entire capacitor. So the entire capacitor plate, the total charge will be electric field density into, so the charge per unit area into the area. Then, so basically from the energy of the capacitor, the formula is this, half q square by c. But we know what the equation for c is. We discussed in the formulas as well. So we just then put both the equation. Then we need to find density. Density is energy per unit volume. So again, we get the energy from the charge. We know the energy of the charge capacitor, and we know the volume of the capacitor. That is the AD is the volume between the plates. So you can consider it the volume of the dielectric media, and then we get the energy density is half into epsilon into E square. So answer is B, half into epsilon into E square. So moving to question 5. So this is a numerical question. So this is something which is quite difficult. I think you should try to solve it yourself as well. So I'll give you the solution, but in case you are not able to solve yourself, or if you haven't tried, I would recommend you to solve it again, and then look at the solution again. So this is the 5th question. So the schematic show of an in-plane accelerometer with crab-like suspension is shown below. Assume that it is made of silicon whose Young's modulus is 169 gigapascal. The thickness everywhere is 25 micrometer. Each square, so here you can see the square grids. They have the size of 5 micrometer by 5 micrometer. In order to perform the self test, so basically just testing the accelerometer, we need to apply some voltage. So for that, and we need to achieve the displacement of 5 nanometer. Basically, in an actual accelerometer, the capacitance is what is measured. So the voltage will be constant. There will be deflection because depending on the direction in which the car is moving, or any object in which accelerometer is being used, so you can see the C1 and C2 are the fixed ones, and the other setup is the moving one. So when the car or any other device will move, the capacitance, so basically the gap between the combs will change, and that will lead to change in capacitance. So from that, that is what is measured in an actual accelerometer. So in this case, we are just testing it. So we are finding the deflection. So in this case, we need the displacement of 5 nanometer. So we want to find out what is the voltage that has to be connected to it. So just I have solved it through hand. So here we have 4 legs. So considering the stiffness of each leg is K. So we have these 2 equations. So these 2 equations are given in the lecture slides also, but just for your understanding, I will just explain them again. So the force is given by N epsilon naught bt. So B is the thickness, that is out of plane thickness, that is perpendicular to the paper, and T is the thickness of the comb, and D is the distance between the 2 combs again, and the mechanical force is given by K equivalent into X. So since there are 4 legs, the total and the deflection will be constant for all the four legs. So the total spring constant will be given by 4 into Ka, and using the formula, because it's a single beam, the formula will be 12 yi upon L cube. So using this equation we find the equivalent spring constant, and then into the displacement, and then we equate it with the first formula of the electrostatic force, that is V square epsilon naught. So okay, so I have made one mistake in the first part, so I have to add V square as well. So yeah, V square n epsilon naught b into T by D, and by substituting in that equation we get the value as 538. So you might be wondering why have we so what is the value of n? So n is basically the combs that are in contact. So in this question it is written that C1 the top fixed comb is not connected to the circuit. So you can see that the top combs we need not consider. So here we have 3 pairs of combs. So 1, 2, 3. So these are the 3 pairs of combs. So the value of n is 3. So the answer is 538 volts. Anyone has any questions regarding this question? It would be better if you ask your doubts regarding this question right now, or regarding the assignment, practice assignment right now, because we'll be moving to the next assignment now. So we'll be moving to the previous year assignment after this. Any doubts? Okay, I'll take it as no. If you want, I'll just wait on the screen. You can just copy it if you want. Okay, so now we move to the previous year assignment. So this is the week 2 assignment. Sorry for the typo. This is the week 2 assignment for the previous year. So here we have one question. So we have 2 charges, Q1 and Q3. Q plus Q and 3Q plus 3Q, placed 1 meter apart from each other. The charge Q minus Q is placed in between them such that all 3 charges are in equilibrium. Find the distance at which Q is placed and its magnitude. So basically here in this figure we can see that there are 2 charges that are there, and we need to find where should we place the negative charge so that the entire system is in equilibrium. So that is in equilibrium is basically the forces acting between plus Q and minus Q, and plus 3Q and minus Q is equal. So we move to the solution of this question. So basically we have to we consider three cases. So in the first case we are having the minus q to the left of both the charges. So this is not possible because it will not be in equilibrium. Again, same for the last case where we put everything to the right, that is also not possible because it will not be in equilibrium. So we have to put minus q in the in between both of them, so not in the center. So what we need to find out is the distance between where we have to keep it. So basically, what if we have to do simple as it is, we have to just equate the two forces using the Coulomb's equation. So basically we use the Coulomb's equation, k q into q x square. So k 3q into q into 1 minus x the whole square. So basically we just have to 1 minus x because we are placing it at distance x from charge q. So it will be 1, since the gap between the two charges is 1 meter, so it will be placed at a distance 1 minus x from charge 3q. So then we get a quadratic equation, and from that quadratic equation we get the two solution. So basically we get two solutions. One is 0.366 and other one is minus 1.336. Basically minus 1.336 is not possible because again it will be outside the it will not be in the center of the two charges, which will again not be in equilibrium. So that way we have to eliminate the second option and we get the first option, that is 0.336. So this is the location of the charge, and to find the force basically we just put it in the equation and we get the charge. So anyone else? I think we have one message. Yeah. What is the answer for question 4? Okay. So we'll just wait for Jenna's answer. We'll just answer her query and then we'll proceed with this because this question is already done. So we'll just move with practice assignment question 4. Yeah, so this is the question 4 and this is the answer. So answer is B. This is how we got it. So basically we have the charge density, we multiply by the area, so we get the charge, and since it's in that dielectric media we just multiply it to get the actual charge in that media, and then we use the energy of the capacitor, charge capacitor equations, and we just put what C formula for C in that equation, and we get the energy of the charge capacitor. But now we need the energy density, that is energy per unit volume. So that is how we get it. So we get the energy of the charge capacitor and then we divide by the volume. So we already know the volume of the dielectric medium will be the cross-sectional area of the capacitor plate into the distance between the two plates, that will be the dielectric medium's volume. So we get this answer. Answer is B, 1 by 2 epsilon naught E square. Okay, so I guess this is answered. So yeah, so anyone has doubt with this question? Question 1. Okay, so yeah, we'll move to the next question. So here we have two um, it's a comb type setup wherein we have two beams, one of both of length 200 micrometer and the distance, that is the area which is in where the capacitance actually acts is 120 micrometer, and the gap between the two is 4 micrometer. So normal force is given by this equation. We have the equation, and the tangential force is given by the equation. Find the relation between normal force and tangential force in the capacitor separated by a distance of 4 micrometers. So very simple answer, very simple question. Just substitute and you get it. So these are the type of questions you'll get in, you can expect in NPTEL, wherein you need to write the equation. You need to actually cut within using your hands, because many things will be unknown and then you will just end up searching for the unknowns. You need not do that. You can just cut everything. So here you can see you wrote the both equation. You can just cancel out epsilon naught, epsilon or b you can cancel out, v square you can cancel out, 2 you can cancel out, d you can cancel out. So what you get when you divide fn upon ft is just x by d. So x is basically, as I said, the area that is of the capacitor is just 120 micrometer, and the distance between the two, as you can see from the previous figure, you can see that even though the length is 200 micrometer, the area of capacitance, because that is the only area where they are parallel to each other, so that is 120 micrometer, and the gap between the two beams is just 4 micrometer. So from that you can just you have divided both normal force and tangential force, and what you have got is normal force is 30 times the tangential force. So whenever you are having any questions during even in your main exam, just try to write those equations, if you and then search for the unknowns, because the majority of the times the equations will be given, the questions will be at similar level of what you get in the assignments. So just but also try to remember the formulas at least once. So to question 3. So mark the incorrect statements. So stiction often occurs when the sample is dried after the etching process. Stiction may be prevented by decreasing the thickness of the beam. For stiction to occur, the addition forces between the beam and the substrate should be lesser than the elastic restoring force acting upon them, and stiction is caused primarily due to capillary action due to surface tension. So basically we have to identify the incorrect one. So Yeah, so the first question, as I said, stiction occurs when you have a silicon substrate, you are making a freestanding substrate. So you have a sacrificial layer, and you have to etch out that sacrificial layer after in the wet etching process. So that is where the actual stiction occurs, because after wet etching is where the fluid or liquid droplets remain. So the statement one is correct. So stiction may be prevented by decreasing the thickness of the beam. No, that is not wrong. That is not right. So basically, irrespective of, I guess I have the figure as well for this. So irrespective of the beam thickness, so here you can see we have two cases where the beam thickness, we have a thicker beam and a smaller beam. Even though the both the beams, the area is different, but still there will be liquid in present there after drying as well. That is because of the surface tension of the liquid, so that will always be there. So that is the case. So the third one, the second option 2 is wrong. So now coming to option 3, stiction occurs due to addition force between occurs. For friction to occur, addition force between the beam and the substrate should be lesser than the elastic restoring force acting upon them. No, it is actually the opposite. If the elastic restoring force is quite high, it can if it can break the bonds. So basically, for the stiction is basically static friction. So static friction is basically there is some kind of bond that is happening between the beam and the substrate. So if the restoring force, if the force that is pulling it is big enough, it can break the bonds, right? So if the bonds are broken, then the stiction will uh, will not occur. So what is they are writing is it should be elastic uh, if the elastic restoring force is greater, stiction will not occur. So yeah, so if the addition force is lesser, the stiction will not occur. So this is the case where this stiction will not occur. So coming to the fourth thing, stiction is primarily caused due to capillary action between the surface tension. Say capillary action due to surface tension. Yes, it is true. So the incorrect statements are statement B and statement C. Anyone has questions? So we'll move to the question 4. So again, these are like simple questions. So statement 1, methanol is a high surface tension liquid. Statement 2, using methanol reduces the capillary pull down force. Methanol is used in the final rinsing step to overcome stiction. So then we have to choose the correct option. So all the above statements are true. Statement 1 is correct explanation of statement 3. 3, but statement 2 is not the correct explanation for statement 3. Statement 1 is false, but statement 2 and 3 are true. Statement 3 is the correct explanation for statement 2. Statement 1 is false, but statement 2 and 3 are true. Statement 2 is the correct explanation for of statement 3, and all the statements are false. So this is these type of questions can be asked to confuse you. Basically, you can see that methanol is not a high surface tension liquid, it is a low surface tension liquid. It is actually used to clean. It is methanol and isopropanol are actually used very widely for cleaning in your laboratory experiment. So you can from that you can see that if it is a high surface tension liquid, it will not flow easily. So it is a low surface tension liquid. So statement 1 is false. So now you know that option A and option D are wrong. But option A is wrong. But now we also know that methanol is used reduces the capillary pull down force, and methanol is actually used in final rinsing of the rinsing step to overcome friction. So these statement 2 and statement 3 are correct. So now we have to find out that which among option B and option C is correct. So now methanol is used in the final rinsing step. So it will always be that statement 2 is the correct explanation of statement 3, because statement B is giving us statement 2 is giving us scientific reason, and statement 3 is an application. So from that you can see that why methanol is used for cleaning is explained in statement 2. So that is how the option C is correct, is the correct option. So any doubts? So moving to question 5. So a micro cantilever acts as a MEMS switch in a circuit which is operational in between 0 to 5 volts. Find the range of potential difference that can be applied across the cantilever to make the circuit on from off state. The length L is 200 micrometer, width and height of the cantilever is 5 micrometer and 2 micrometer respectively. The Young's modulus is 169 gigapascal, and the deflection is G naught. That is the gap between the two beams is 1 micrometer. So again we have this is a pull voltage equation question. So here we have to use the pull-in voltage equation. So but we need to find out the effective K, so effective stiffness of the beam. So we are finding that using the equation Y WH cube upon 4L cube. So for all this effective beam stiffness, you have to refer to week 1 content. In that all the formulas are given in detail, so you can refer that. And so from that you know that pull-in voltage is 2.65. So as I said earlier, the circuit will be on when the voltage exceeds the pull-in voltage. So when the circuit will only be on when during the time the voltage is more than 2.65, and since the operational voltage is 5 volt, so the circuit will always remain on between 2.68 to 5 volt, because in this case the mechanical force, the electrostatic repulsion is actually greater than the mechanical restoration force. So any questions? Okay, then I'll take it as a no. So yeah, so this is the question 6. Capacitance of two coaxial cylinders having permittivity epsilon, radii a and b, and length L is given by which of the following equation? This is again a very simple question. So you use Gauss law. So here we use Gauss law. So then we integrated over the particular area. We substitute B and A and get the capacitance using this equation. So the answer is 2 pi epsilon L ln B by A. So any questions? Okay, then we'll move to the 7th question. So for the system given below, the ratio of displacement, if the voltage applied across the plates is 4 volt and 10 volts respectively, the tangential force on each plate and the tangent force on each plate of a parallel plate capacitor is given by this formula. So you can see in most of the questions the formula is given. You just have to substitute in the formula, and here we are doing the same thing. So we know what the tangential forces it is given in the formula. So we just equate the tangential force with the mechanical force, and since there are the forces acting from two directions, so the force is acting from upwards as well as force is acting from downwards, so we multiply the force by 2, and then we just find this equation, so where we find the relation between the gap and the voltage, and likewise we just find out that the ratio, likewise we find the ratio between the tangential forces in both the cases when the voltage is 4 volt and 10 volt, and then we get the answer as 0.16 as the answer. So anyone did understand this? Okay, then moving to the 8th question. Consider a parallel plate capacitor whose capacitance is given by C A epsilon naught by D. So here we know that it is not in free space, it is in a media because we have epsilon. So A is the area of the plates, D is the distance of the parallel plates, epsilon is the permittivity in the space, and assuming epsilon 0 to 1 dielectric constant of the material that is put between the plates, the capacitance C is doubled if, so we have 3 cases here. If the distance between the parallel plate D is halved, if the area of the plates A is doubled if the dielectric of the dielectric constant is multiplied by 2, and the distance between the parallel plates is D is doubled. So here we have 4 cases. So this is a multiple choice question. So here we substituting each of the case. So we have the equation that has been given to us earlier. We just substitute in that equation. So in the first case, which is half the distance, so we see that the capacitance is doubled. We change the area to twice A. So again we see that the capacitance has been doubled. Then in the third equation we change the dielectric constant to 2. Again we see that the capacitance is doubled, but in the last case we see that the distance is doubled, but the capacitance is halved, because of the inverse relation we can see that the capacitance is halved. This is a very simple question. You just need to write down the formula, just substitute all the cases, and you will get the answer. So sometimes the question might look difficult, but the question will be very easy. So please attempt all the questions during the exam. Anyone has any questions? Okay, so moving to the last 2 questions. So in this, a pull-in voltage of the cantilever beam as shown in the figure below does not depend on the thickness of the beam. So it's a true or false question. We have to say whether it's true or false. So it's false. Basically we have the pull-in voltage equation. So in that we have to find the stiffness, the equivalent stiffness of the beam. So that is obviously dependent on the thickness of the beam. So again it comes into that will come into effect while finding the pull-in voltage. So again that's a false statement. So based on the same figure we have another question. So if the gap G2 is half, so if we half the gap, so will the pull-in voltage decrease? So yes, it will decrease. So pull-in voltage is proportional to G 3 by 2. So in the lecture also it is given that the distance at which the pull-in voltage takes into account is D by 3. So yeah, if the G2 is half, the pull-in voltage will decrease. So with this we have ended the practice assignment 2 and the previous year assignment 2 as well. So if anyone has any doubts, please unmute yourself and ask your doubts. Okay, these questions are from previous year assignment. So we are supposed to like practice for solving this year's assignment. So these assignments are from previous year. These questions are from previous year's assignment. So anyone has any questions? anything, any advice you would want for the exams or something, you can just unmute yourself because we have a lot of time. So next week it will not be that easy because next week we'll be going deep into MEMS fabrication. So this week we have some time. Your assignment score basically you will come to know after the date is passed. So after that assignment date is passed, you'll get to know within 1 week or something. So basically, when we make the assignments, we actually send the answers as well to NPTEL. So it is basically NPTEL already has the answers. So they just whenever they run the program, they usually do it in 1 week or so. So in that you will get your assignment score. Can you please just text your backgrounds in like in the chat or something? If you are not comfortable unmuting yourself, you can just text your background in the chat, like whether you are undergraduate, postgraduate, PhD, faculty somewhere. Can you just text your backgrounds, please? Okay. So you have BTech background, so you will be able to grasp this very easily. So what you will get in next week might be a bit tougher because my MEMS fabrication is something which is novel and it has come to India in last few years itself. So if you are already working, so I can see that you have done BTech and then done B.Ed as well. So these things you might not have done during your study. So next week just go through all the lectures also quite well, and that's a very interesting field actually. So you can just go through the field, go through the videos as well, and maybe try to search more videos online as well. So just have a look at all those things for the next week because it's a very important subject and it is basically the future. So that is something which you will enjoy a lot, hopefully. Anyone else? Can you give your background or something so that, like, if I can help you or give you some advice, or if you have any questions, please, regarding all the assignments we solved, the 15 questions we solved, please. seeing any response from others. So yeah, I mean, if you we won't be discussing anything beyond this. So unless if you don't have any question, you can just leave the call. I'll just keep the session open for people who are joining in late. I won't waste your time. So if you are, if you don't have any questions, you can just leave the call. I'll just keep the call open for latecomers. No problem. Thank you. Anyone have any questions? If you want any advice for this course, that also you can just maybe unmute yourself, or you can write in the chat as well, whichever way you are comfortable with. So those joining late, basically we discussed the practice assignment, and the previous year week 2 assignment. So we discussed the following. So here so the practice assignment question. So we discussed question 1. So 4 particles, each with charge q, are placed in the corners of a square. The another charge q of opposite sign is placed at the center of the square, such that the total force on each particle is 0. Which of the following relation is correct with regarding to charges q and q? So we basically take the equilibrium, and for only two charges, because if we take the equilibrium for the whole system, all the charges at the corner will cancel out each other, and only the charge at the center will remain. So for that we just take the equilibrium between the two charges, and then we substitute that. So here we already have F3 and F4. So F1 is basically we can using basic trigonometry, we know that it is symmetric, so we just have to find out the resultant. The resultant is root 2 of F1. So using that equations, we find out the relation between q and both the q's, so that it is in equilibrium. So this is the relation. The answer is B. So moving to the second question. So we find out the capacitance of the concentric metal shells with radii A and B. So we use the tool this equation. So basically we find the we know the constant K. So from that we substitute the potential at one shell in the capacitance equation. Again the same we do for the second shell. We find out the potential difference, and then we again resubstitute the potential difference in the capacitance equation, and then we get the equivalent capacitance of the entire system. So coming to the third question. So this is the statement type of questions, wherein if you have two equations, we are being given with two equations, two equations and two statements. So basically we need to find which of the things are correct. So from the lecture slides you already know that this is the correct equation for normal force under tangential force, and then we substitute B epsilon naught epsilon r V square upon 2D with K, and then what we get in the normal force is x by d. So you already know from the data that x is way greater than d, so x by d will be way greater than 1. So what is given in the statement 2 is wrong. So only statement 1 is correct. fourth question, we have the electric energy density in the parallel plate capacitor. It is given already to us. If the electric field inside is E, then the energy density is given by. So we already know charge is epsilon naught into electric density into the area. So charge density into area will get the charge, and then you know the energy of the capacitor equation. So we just substitute everything. Then we find out um, energy density by basically dividing the energy by the volume. So volume we already know is A by D, that is the cross section area of the capacitor plate and the distance between the two parallel plates, and this is how we get the energy density. So the answer is B. So for the fifth question, this is a numerical type of question. The schematic of an inclined accelerometer with crab-leg suspension is shown below. Assume that it's made up of silicon whose Young's modulus is 160 megapascal. The thickness everywhere is 25 micrometers. Each square grid has a size of 5 micrometer by 5 micrometer. So what should be the voltage applied to achieve the displacement of 5 nanometer? So here we are solving it. Basically we find the stiffness of one leg, then we find the equivalent system stiffness of the entire system, and then we just equate the two equations, the force, the electrostatic force and the mechanical force. We just equate them, and then we get the voltage value as 538 volts. So anyone has any questions on assignment, practice assignment? So does anyone have any questions? any questions from your side? It need not be regarding the assignment. You can even ask me questions regarding the coursework, or even in general about, like, if you want to discuss something about sensors, or basically something, if you want any guidance regarding your if you're doing your PhD or something, then I can help you with that as well. Or you're doing your BTech, MTech projects regarding sensors or MEMS, if you want to have any, if you need any um, suggestions, even regarding, like, if you want to do something in MEMS and you want some like help in selecting, finding research papers and something, you can just discuss it with me. I can help you with that as well. Because this is the only time you get to interact with somebody who are doing their work in this area. So I would suggest you can take good opportunity with this. If you need something from IIT background, something, I can help you with that as well. So I would encourage you to ask questions. So I believe that none of you all have any questions per se. So you can just leave the session as well, and I'll just keep the session open for the latecomers. whoever joined it now, basically we discussed practice assignment for the second week, as well as the previous year assignment for the second week. So if you have any questions regarding second week content, you can just unmute yourself and ask your doubts. You can also ask something regarding sensors as well, like if you want to know more about MEMS processing or MEMS, how MEMS fabrication is done, what are the recent advances in MEMS, and if you're doing something in your BTech or MTech projects, and if you want some advice regarding that, you can also just ask your questions here as well. You can just unmute and maybe we can all brainstorm if you have any problem with your BTech, MTech, or even with your PhD. So I would encourage you to unmute yourself and present your questions in this session, because basically we are all here to learn, and if we get something additional along with the assignments, it would always be helpful for all of us. If you are hesitant, you can even type in the chat, doesn't matter. You can type in your questions in the chat. That also I'm monitoring right now. So whatever it is, please just use this forum, because this is the second session. There will be only 2 more sessions, and most probably the next session will be quite exhausting, and we'll be actually going through MEMS processing in deep with lot of videos and everything. So today is the only session you'll actually get to interact with us. So please try to use this session. If you have any doubts, if you need any suggestions, please try to put that in the chat, or you can unmute yourself as well. In case you don't have any question, you are free to leave the session, so that it will be better. You can save your time as well. So for those joining in late, we have discussed practice assignment 2 and previous year's assignment 2. I would really request you to go through it, maybe through the recorded videos and recorded and the lecture slides, because these are the questions which might get you, which might come in your final exams. Um, Now, if you have any questions regarding MEMS, regarding the week 2 content, regarding MEMS, have any problems with your BTech MTech projects, and if you need any advice from like us, in, feel free to unmute yourself and post your questions, or if you are too hesitant, you can even put your things in chat as well. Put ask your doubts in chat as well. I think nobody has questions, so I would like to formally end this session. I would like to thank you from my side, and I would see you next week. Hello. Yeah. Do you have